On a typical morning at the Tesla factory with its production line, the clang of metal, the steady hum of engines, and the motion of thousands of robotic arms create a modern industrial atmosphere. Tesla Optimus begins its shift. Elon Musk once said that Optimus would redefine the meaning of productivity, and witnessing a Workday of the latest Optimus version increasing the production line's efficiency by 50% in a single shift makes that statement clear. So, what tasks does Tesla Optimus perform? And what is Tesla's latest plan for its humanoid robot? Don't click away. In the next 30 seconds, I'll show you Tesla's most secret update about Optimus. Before we begin, if you love staying ahead on Tesla and AI tech, hit subscribe now. You'll be the first to know the breaking news. Optimus steps onto the production line like a true worker. But unlike humans, it doesn't need rest, protective gear, or worry about mistakes caused by fatigue. The robot's first task is assembling electronic components for Tesla's vehicle control systems at a speed of 120 components per hour. The remarkable part here is not the mechanics, but its eyes. Tesla has equipped Optimus with a 32-megapixel multispectral camera system, depth sensors with 0.1mm accuracy, and computer vision AI processing 1,000 frames per second, enabling it to observe, recognize, and process information 20 times faster than a human. Instead of relying on fixed jigs to place components correctly, Optimus simply looks, analyzes the shape and position, and adjusts its mechanical hand with extreme precision. A tiny 3mm chip is inserted into the slot without being off by even 1/100th of a millimeter. This is the breakthrough that has led many technology experts to admit that Optimus is no longer just a rigid industrial robot, but a humanoid worker capable of adapting to real-world environments, achieving 99.9% accuracy in assembly tests. After completing a series of assembly tasks, Optimus does not move to a new position like traditional robots that must slide along a rail. Instead, it simply rotates its torso 180 degrees, leans 45 degrees, and extends its arm 1.2 meters to the side to begin the next job. The conveyor brings forward the metal frames that need reinforcement, and Optimus handles them with an average processing time of 5 seconds per component. Tesla designed Optimus as a flexible link in the production line, reducing movement time by 30% and saving 25% of floor space. From a production management perspective, this alone improves efficiency by 20%. The next impressive aspect of Optimus's Workday is its ability to operate continuously without breaks. This does not come from the robot's endurance, but from Tesla's implementation of wireless magnetic resonance charging technology, achieving an energy transfer efficiency of 95%. During the 5-minute pauses when the production line switches materials or undergoes quality checks, Optimus can stand at its designated spot, where a 10-kilowatt magnetic charging base is installed. As soon as it stops, energy is transmitted directly into the robot's integrated 4,680 battery pack, with a capacity of 50 kilowatt-hours, similar to how some Tesla electric vehicle prototypes are tested with wireless charging in parking lots. This technology has already appeared in other fields, from wireless phone charging to medical applications for implanted devices. But Tesla has elevated it for industrial production, where 5 minutes of charging provides 4 hours of continuous work. Thanks to this, Optimus can maintain 24/7 operation, with up to 96 hours of uninterrupted runtime before requiring maintenance. Throughout the day, Optimus works seamlessly with 150 other robotic arms on the production line. While traditional industrial robots repeat pre-programmed motions, Optimus has been trained with reinforcement learning over 15 million cycles, allowing it to adapt its actions to context. If a component is misaligned by 2 millimeters, it can adjust its movement with a margin of error of just 0.1 millimeters. If the line encounters a minor issue, it can pause its assembly task and switch to handling another process within 3 seconds. This makes Optimus a true colleague to the fixed machines, bringing flexibility with an automatic error handling rate of 98%. Tesla reports that production efficiency, thanks to Optimus, has increased by 50%, equivalent to raising output from 1,000 to 1,500 units per day. This improvement doesn't come from speed alone, but from stability and adaptability. A human worker, even highly skilled, can still make errors at a rate of 2 to 3% due to distraction, fatigue, or stress. Optimus reduces the error rate to under 0.1%. Moreover, its ability to receive remote software updates allows Tesla to improve the skills of thousands of Optimus units simultaneously, just as they update self-driving software for electric cars, with each 50-megabyte update taking only 30 minutes. Overnight, the entire robot workforce can be upgraded with new skills, something no company could ever achieve with a traditional human workforce. What attracts the most attention from the business community is the cost. Tesla announced that the production cost of each Optimus is $10,000, with annual operating costs under $2,000. By comparison, an average worker in the United States earns around $45,000 per year, not including insurance, benefits, and training expenses. Meanwhile, a single Optimus priced at $10,000 can replace 3 workers on a production line, handling 360 components per hour. The profitability equation becomes very clear. The initial investment pays for itself in 4 months, with long-term profits increasing by 300% after the first year. Elon Musk once stated that Optimus has the potential to spark an economic revolution similar to when the steam engine replaced manual labor in the 19th century. At the end of the day, as many workers leave the factory to rest, Optimus still stands there, working alongside other machines, tireless, without complaint, ready to continue after just 5 minutes of charging. That image is not only a symbol of technological progress, but also raises a profound question for society. When robots can work non-stop at 80% lower cost than human labor, how will the role of humans in production change? Elon Musk may have anticipated this when he said humanity must prepare for an era where robots are no longer just auxiliary tools, but the primary workforce. A workday of Optimus in the Tesla factory is not merely a technical description, but a reminder that we are stepping into a new age. This generation of humanoid robots can observe with machine eyes at 16-megapixel resolution, assemble with 0.05 millimeter precision, coordinate seamlessly with the production line, maintain 24/7 productivity thanks to 10-kilowatt wireless charging, and deliver labor costs lower than ever before. This transformation not only boosts efficiency by 50% within a single factory, but also opens the prospect of redefining the entire global industrial model. What kinds of tasks would Optimus perform in a day at a factory to generate income for its owner? A completely unprecedented plan, yet one worth discussing in depth as it opens up a new idea for Tesla in 2026. The claim that Tesla Optimus, an advanced industrial robot, can multiply an investor's assets 5-fold through its ability to generate $25 per hour of income at an operating cost of only $5 per hour has drawn considerable attention. With an initial investment of $10,000 to own an Optimus prototype, this model promises substantial profits, making it a compelling investment opportunity. The plan is based on a leaseback model in which Tesla rents the robot back from its owner and pays $25 per hour to use Optimus in manufacturing facilities. The financial potential and its implications for the future of automation are worth analyzing. First, let's look at the financial potential of investing in Tesla Optimus. Assuming the robot works 8 hours a day, 5 days a week, at a rental rate of $25 per hour, and an operational cost of $5 per hour, we can calculate the monthly profit. Each hour, Optimus generates a net profit of $20 after deducting the operational cost. With 40 working hours per week, the weekly profit is $800. Over the course of a month, assuming 4 weeks, the total net profit amounts to $3,200. Given the initial $10,000 investment, the payback period is just over 3 months, which is impressive compared to traditional investment channels like stocks, with an average annual return of 7 to 10%, or real estate, with returns around 8 to 12% per year. After recouping the initial investment, Optimus continues to generate a monthly net profit of $3,200, or $38,400 per year. In terms of annual return, this investment yields 384%, a figure far exceeding most current investment opportunities. However, these numbers are purely theoretical and depend on several factors, including the robot's reliability, additional maintenance costs, and Tesla's ability to sustain the leaseback model. Although the profit potential is highly attractive, this plan is not without risks. One of the biggest risks is the stability of the technology. Optimus is a pioneering product, and technical issues such as software bugs, hardware failures, or underwhelming performance could reduce uptime and impact income. Additionally, the publicly stated $5 per hour operating cost may not include hidden expenses like regular maintenance, software upgrades, or additional electricity consumption. If these costs exceed expectations, net profit could shrink significantly. Another factor to consider is the reliance on Tesla. The leaseback model depends on Tesla maintaining a steady demand for Optimus in its manufacturing facility. If Tesla scales back production, shifts its strategy, or faces financial difficulties, the owner's income could be disrupted. Moreover, competition in the industrial robotics industry presents another challenge. If other companies develop cheaper or more efficient automation solutions, the value of Optimus may decline, and the $25 per hour rental rate may no longer be sustainable. Despite the risks, investing in Optimus offers a promising long-term vision. Owning a robot like Optimus is not just a financial opportunity, it's a way for investors to participate in the automation revolution. With the advancement of artificial intelligence and robotics technology, Optimus could be upgraded to perform more complex tasks, increasing its value and profitability. If Tesla expands the leaseback model into other sectors, such as warehousing, logistics, or even home services, the potential revenue could grow significantly. However, this model also raises questions about control. Since Tesla requires usage rights for the robot in its factories, owners may be restricted from deploying Optimus for other purposes. External factors such as tax policies, industrial robot regulations, and economic fluctuations could also affect long-term profitability. Therefore, investors must carefully weigh the potential returns against the inherent risks before getting involved. To better understand how Optimus generates value, imagine a typical workday for the robot at a Tesla factory under the leaseback model. At 8 a.m., Optimus begins its workday with a self-diagnostic check, inspecting sensors, AI software, and mechanical components. The robot then connects to the factory network to receive instructions from the production management system. During the first hour, Optimus performs light tasks such as moving materials or preparing tools, generating a net profit of $20 after subtracting operational costs. From 9 a.m. to 11 a.m., Optimus shifts to assembling complex components like battery modules or electric drivetrains. Thanks to AI-powered precision, the robot completes tasks faster and with fewer errors than human labor, producing a net profit of $40 over those 2 hours. From 11 a.m. to 12 p.m., Optimus conducts quality control, using visual sensors and AI to detect minor defects like cracks or dimensional deviations, adding another $20 in net profit. Between 12 p.m. and 1 p.m., Optimus pauses for quick maintenance, recharging, and software updates if needed. During this break, the robot doesn't generate revenue, but the $5 operational cost still applies to maintain basic activity. After the break, from 1 p.m. to 3 p.m., Optimus handles logistics and warehouse management, transporting large components like vehicle frames or battery packs from storage to the assembly line. With its heavy lifting capability and intelligent navigation, the robot optimizes the logistics flow, generating $40 in net profit over these 2 hours. From 3 p.m. to 5 p.m., Optimus supports the assembly line with tasks such as automated welding, structural installation, or assisting other robots. This is a high-value phase, adding another $40 in net profit over 2 hours. In total, during an 8-hour workday, Optimus generates $200 in revenue and incurs $40 in operational costs, resulting in a net profit of $160 per day. This aligns with earlier estimates, $800 in weekly profit and $3,200 monthly. Tesla's leaseback model offers mutual benefits. For owners, it provides a stable stream of passive income, $3,200 per month, without the need for directly managing the robot. With an initial investment of $10,000, it's an attractive opportunity for individual investors, especially those looking to enter the high-tech sector. For Tesla, this model helps the company optimize labor costs by leasing robots instead of purchasing new units, while leveraging Optimus's AI to boost factory productivity. Furthermore, the model encourages community involvement, creating an economic ecosystem around Optimus, where individuals are not just consumers, but partners in Tesla's growth. However, Optimus's work process also faces several challenges. Downtime due to maintenance or technical failures can reduce effective working hours, which in turn impacts profitability. Additionally, Optimus needs to be programmed to adapt to different tasks within the factory. If production demands change, the robot may require software or hardware updates, adding extra costs for either the owner or Tesla. Moreover, if Tesla scales the leaseback model to thousands of owners, Managing a large fleet of Optimus units in the factory could lead to congestion or programming conflicts. To ensure success, Tesla will need to invest in an effective robot management system and maintain Optimus's reliability in the production environment. How does Tesla Optimus's brain work? How is it superior to humans? The structure of Optimus's AI brain begins with Tesla's long history in autonomous driving. For over a decade, the company has trained its cars to recognize lanes, pedestrians, traffic signals, and complex road scenarios using 1.5 billion miles of driving data. That knowledge provided the baseline for how a humanoid robot could learn to see the world. 8 cameras mounted on Optimus, with a combined resolution of 16 megapixels, feed high-bandwidth streams at 120 frames per second into a cluster of Tesla-designed AI chips. These are not off-the-shelf GPUs, but custom dojo-like architectures optimized for low-latency decision-making, achieving 1.2 trillion operations per second with a power draw of 250 watts. At the lowest level, convolutional neural networks parse raw pixels into edges, textures, and objects with 98% accuracy. On top of that, transformer-based models with 12 billion parameters build temporal memory, enabling the robot to anticipate movement patterns, track the trajectories of human coworkers within 0.1 meters, or infer the weight of an object to within 50 grams before lifting it. The principle is simple but revolutionary. The AI brain works not in isolated loops, but as a deeply integrated sensory motor cortex. Vision is not separate from planning. Proprioception from 128 torque sensors feeds into the same neural net that processes video at 100 Hz. This mimics the way human biology merges sensory input with motor planning. The result is fluid motion. When Optimus reaches for a part on the factory line, its 22 degree of freedom fingers predict micro adjustments in grip force within 0.01 Newton, because the visual network has signaled potential slippage with 95% confidence. Such coupling of perception and action is a major leap forward compared to earlier humanoids that relied on rule-based control, with error rates of 10 to 15%. Deep reinforcement learning provides the second foundation of Optimus's intelligence. Rather than hand-coding instructions for every movement, engineers allow the robot to learn through 15 million simulated trials, rewards, and corrections. In simulation, Optimus performs 10 million pick-and-place tasks, 5 million walking gaits, or 2 million cooperative maneuvers with other robots. Success is encoded as reward signals, while mistakes trigger backpropagation through the network. The sheer scale is breathtaking. Tesla's AI training pipeline processes 2 petabytes of video per day, with Optimus training consuming 500 terabytes daily. In practice, this means Optimus can adapt to new tasks 10 times faster than a human. Where a child might take 6 months to master dexterous hand-eye coordination, Optimus compresses that learning into 48 hours by leveraging reinforcement at industrial scale, achieving a task success rate of 97%. Memory, often overlooked in robots, is crucial for Optimus. A child learns by building an internal model of the world. Optimus uses recurrent networks with 8 billion parameters and vector databases storing 1 terabyte of task data to recall past tasks. When it tightens a bolt with 20 Newton meters of torque, it stores torque values and hand trajectories with 0.05 millimeters precision. The next time it encounters a similar bolt offset by 2 millimeters, it applies the old strategy with minimal adjustments, reducing task time by 30%. This transfer learning gives Optimus continuity across 150 distinct tasks. Unlike earlier robots that reset after every cycle, Optimus accumulates skill. Each hour in the factory adds 500 megabytes of experiential data, making the robot smarter over time. Real-time data processing is another cornerstone. Human cognition processes visual input in under 200 milliseconds. Optimus matches this with a latency of 30 milliseconds, achieved by combining sensor fusion and edge computing. 8 cameras, 4 microphones, and 128 force sensors stream data at 1000 Hz into a central processor. This allows Optimus to hear verbal instructions, interpret them through a speech recognition model with 95% accuracy, map the request to a task library of 10,000 entries, and begin movement within 50 milliseconds. Even in noisy factory environments with 100 decibel sound levels, Optimus filters acoustic signals and synchronizes them with lip motion detection from cameras, reducing ambiguity by 40%. Such multimodal AI ensures Optimus responds as naturally as a trained coworker. Comparison with rivals reveals why Tesla's approach is disruptive. Unitree's humanoid prototypes rely on predefined motor control patterns, achieving only 85% task adaptability. Figure AI has made progress in dexterous manipulation, but its models depend on third-party cloud training, with 200 millisecond latency and lack Tesla's vertical integration of 50 billion miles of driving data, chips, and vehicles. Optimus V3.5 enjoys a unique edge. Its AI is refined from 10 million robot trials and 1.5 billion miles of driving data, with perception models achieving 98% robustness and decision-making tested over 100,000 real-world scenarios. Concrete numbers highlight this advantage. Internal benchmarks show Optimus achieving task learning speeds 10 times faster than traditional humanoid platforms. In controlled trials, a set of 100 assembly tasks that took human trainees 40 hours to master were reduced to 4 hours for Optimus, with an error rate of 1.8% compared to 12 to 15% in rival systems. Real-time inference throughput reaches 1.2 trillion operations per second, while power consumption remains under 250 watts. These figures derive from the scaling laws of Tesla's Dojo supercomputer, applied to a humanoid context. The broader impact of this AI brain extends beyond Tesla. If Optimus can learn 150 tasks in 48 hours, industries will recalibrate expectations. Manufacturing will deploy robots in 3 days instead of weeks. This dynamic capability impacts logistics, handling 200 packages per hour, and elder care, supporting 20 daily tasks. Globally, humanoids could fill gaps in aging populations, with Japan's workforce shrinking by 11% by 2030. Developing economies could deploy Optimus in sectors where training costs exceed $10,000 per worker. Tesla's decision to merge reinforcement learning, deep vision, multimodal processing, and hardware optimization challenges the fragmented approach of academic AI. It demonstrates that intelligence grounded in physical action is robust. Algorithms accounting for gravity, friction, and fatigue become 30% more generalizable than those optimized in digital games alone. This insight will inspire new AI architectures and benchmarks. Tesla's closed-door research suggests Optimus's AI brain is evolving towards semi-autonomous goal setting. In early lab experiments, the robot broke down complex tasks into 10 sub-goals without explicit programming, an emergent property of its 20 billion parameter architecture. This meta-learning places Tesla ahead of rivals struggling with basic dexterity, with Optimus achieving 95% task autonomy in controlled tests. Cost efficiency is notable. While training consumes 100 petaflops of compute, inference on-device uses 250 watts, akin to a laptop. Training costs of $5 million are amortized over 10,000 robots, while each unit's daily power consumption is 2 kilowatt-hours. This allows Tesla to promise humanoids at $20,000 while equipping them with world-class AI. Ultimately, the Tesla Optimus V3.5 is a showcase of embodied intelligence. Its brain, layered with perception, reinforcement, memory, and planning, learned faster than a child, standing on 1.5 billion miles of driving data and 100,000 GPU hours of training. As industries adopt Optimus, as households encounter it, and as researchers study its emergent behaviors, the AI landscape will shift. The Optimus AI brain proves intelligence is not abstract. It is electrons, sensors, and actuators fused into a system that learns by living, carrying the AI frontier forward with every precise movement on the factory floor. Optimus's learning process begins in an ultra-realistic simulation environment created by Tesla's software team, using high-precision physics and 3D vision engines. In this environment, Optimus can go through millions of scenarios each day, the equivalent of 10 million trials per week, without causing any wear on its hardware. For example, to teach the robot to grasp an object as thin as a sheet of paper, the AI will test thousands of variations of the gripping motion, changing force, angle, and speed, and receive instant feedback from the simulation on its success rate, reaching 99% accuracy in simulated scenarios. This is the power of reinforcement learning. The system continuously experiments, receives rewards when it meets the target, and adjusts its action policy to maximize cumulative rewards. As a result, after just 4 hours in the virtual environment, Optimus can master a skill that previously took 3 weeks to program manually. When moving into the real world, the data and policies learned from simulation are micro-adjusted through on-site training sessions, cutting fine-tuning time from several weeks to under 48 hours. At this stage, Optimus's AI applies its existing knowledge while learning additional variables that the simulation cannot perfectly replicate, such as material slipperiness, vibrations from the floor, or changing light conditions. This technique is called sim-to-real transfer, a critical step in turning virtual knowledge into real-world skills. Tesla optimizes this process by using deep neural networks capable of real-time self-adaptation, combining force, vision, and even audio sensor data to assess situations more comprehensively, achieving up to 99.5% sensing accuracy in real-world conditions. Optimus's ability to remember and apply experience is also an integral part of Tesla's AI architecture. Instead of handling each task in isolation, Optimus stores state action representations in long-term memory, allowing it to recognize patterns in situations it has encountered before. When tasked with a new job that shares similarities with a previous one, the robot doesn't learn from scratch. It reuses proven strategies, fine-tuned for the differences, reducing learning time from several days to just 1 or 2 hours. This approach is akin to human life experience. Someone who has learned to ride a bicycle will pick up riding a motorbike faster because they already understand the principles of balance and steering. Comparing the learning speed of Optimus with that of humans reveals a striking difference. A child takes around 20 months to master fine motor skills such as tying shoelaces, but Optimus, when trained using reinforcement learning combined with simulation, can achieve comparable accuracy in just 4 hours. This comes from its ability to perform millions of trial-and-error iterations without fatigue, collect and process sensor data at a rate of 5 gigabytes per second, and train on multiple tasks simultaneously, without forgetting previously learned skills, a common weakness in many other AI models, while maintaining an error rate of only about 2%. The application of this learning process in training robots for new tasks opens up massive potential for Tesla. For example, if a factory needs Optimus to take on a new assembly procedure, engineers only need to provide a task description and the basic physical parameters. Within 24 hours, Optimus can undergo millions of virtual training runs, adjust its strategies, and be ready for real-world deployment with a success rate as high as 90% on the first attempt. Tesla also envisions connecting multiple Optimus units so that when one robot learns a new skill, it can transmit its action policy to hundreds of others, transforming training from a sequential process into a global parallel one, boosting training efficiency by up to 100 times compared to sequential methods. What makes TeslaBot stand out is the integration of multiple layers of technology. Deep reinforcement learning that optimizes action policies with 95% efficiency. Transfer learning that reuses knowledge across tasks with 90% efficiency. And multitask learning that allows the robot to maintain and upgrade multiple skills simultaneously, achieving a 98% success rate in complex tasks. As a result, whenever Optimus learns something new, it not only becomes better at that specific task, but also grows more flexible and efficient across dozens of other tasks as well. Beyond industrial applications, Optimus also brings significant real-world value to the elderly, helping them live more independently and safely in their daily lives. With its self-learning and adaptive capabilities, the robot can assist with everyday tasks such as simple cooking, house cleaning, or timely medication retrieval, reducing the risk of household accidents by up to 70%, according to studies on elder care robots. For example, Optimus can monitor health through sensors, detect falls, and call for emergency assistance immediately, or engage in conversation as a companion to reduce feelings of loneliness. It integrates a friendly AI voice to remind users of doctors' appointments or assist with mobility around the home. In family settings, the robot can provide nighttime care without disturbing relatives, such as helping with bathing or changing clothes, achieving a high success rate thanks to training from real-world videos and adjusting to individual needs. These applications not only enhance quality of life, but also reduce the burden on healthcare systems, especially in countries with rapidly aging populations like the United States. With this approach, Tesla is building an AI platform where Optimus's skill evolution rate can be 100 times faster than humans. This does not mean robots will completely replace humans. Rather, they will rapidly become collaborators capable of self-learning, self-improvement, and knowledge sharing, expanding human capabilities in environments and tasks that were previously impossible. What do you think about this? Feel free to share your thoughts in the comments section below. We hope to bring the best information to you. Please give a thumbs up if you like this, Join Techno Creator by subscribing and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.